Hi, good morning everyone. Today I would like to share with you the Fourier transform property time reversal. So this is the properties of the time reversal. The Fourier transform of x negative t, you will get x negative omega. Okay, now let's look at the example. Okay, class. So you have the given the xt is exponent negative 2t ut, and the Fourier transform of xt is 1 over 2 plus j omega. Okay, so this one, okay, this is the question. Then you need to find the x negative t. So this negative refer to the reversal. So x negative t, you will get what? Negative, right? So it's minus. So your xt you will get is exponent negative 2t ut. So, and the Fourier transform you will get 1 over 2 plus j omega. If negative t means 2 minus j omega. So you will get 2 minus j omega. Okay, next question. If I have x negative t over 2. Okay, as you know, x t over 2. So this t over 2 is referred to the scaling. Okay, you get it from the previous question. You get 2 over 2 plus j 2 omega. Okay, and then x negative t over 2, you get what? Okay, you get reverse, right? 2 minus 2 over 2 minus j 2 omega. Okay, next look at another question. X 2 minus t over 2. Okay, x 2 minus t over 2, you can change to x 4 minus t over 2, or you can change to x minus t minus 4 over 2. Okay, or you can write it at x negative 0.5 t minus 4. Okay, so we do the shifting first. So x t minus 4, we get exponent j negative j omega 4 x omega, right? So x omega is referred to 1 over 2 plus j omega lah. And then x 0.5 t. So this is the scaling. So scaling, you get exponent j omega 4. Oh, sorry. It's not j omega 4. For the scaling is you get 2. Okay, 2 plus j 2 omega. Because 1 over 0.5 you get 2. Okay, then for the reversal part is x negative t. If x negative t, you will get x negative omega. Okay, now we put it all together. If I have 0.5 t minus 4, I would have exponent j omega 4 times with 2 plus j 2 omega. If I have negative 0.5 t minus 4, I would have exponent j omega 4 times with 2 over 2 minus j 2 omega. Okay? Okay, class, let's look at another example. If you have the x1 equal to delta t and x2 equal to exponent j omega naught t, find the Fourier transform of the find the Fourier transform of 3x1t plus 5x2t. Okay, so like this. So you have the xt equal to 3x1t plus 5x2t. Then you will have the x1 is 3 delta t plus 5x2. So x2 is exponent j omega naught t. So by using the Fourier transform table, you can get it x omega equal to 3. Okay, you can check to the Fourier transform table. Okay, if you look at the delta, this is a Fourier transform table. If you look at the delta, you will get 1. Okay, so 3 multiplied with 1 plus with 5. Okay, exponent j omega naught t. exponent j omega naught t, so equal to 2 pi delta omega minus omega naught. Since it's a positive, okay, you also have the, if you have the positive j omega naught t, here also positive. So 2 pi delta omega plus omega naught. So you have 3 plus 10 pi delta omega minus omega plus omega naught. Okay? So delta equal to 1, and the exponent j omega naught t, you get 2 pi delta omega plus omega naught. So you can simplify, you get this answer. Okay, let's look at another example. From the property tables, linearity property, you have ut equal to pi delta omega plus 1 over j omega. And you have 1. 1 is referred to the 2 pi delta omega. So x omega equal to 2 pi delta omega plus 2 pi delta omega plus 2 over j omega. That is equivalent to 4 pi delta omega plus 2 over j omega. Okay, let's look at this example. Find the Fourier transform of xt minus 2 where the xt is 1 plus 2 ut. Okay, so you know that xt is 1 plus 2 ut and xt minus 2 is equivalent to 1 plus 2 ut minus 2 because the t is minus 2. So this is referred to the shifting properties. Shifting property. Okay, shifting properties, in which the xt minus t naught, you will get the x omega exponent minus j omega t naught. So xt minus 2, you will get x omega exponent minus j 2 omega. And the xt minus 2 refer to the 1 plus 2 ut minus 2, right? So this is referred to x omega exponent j minus j 2 omega. So x omega you get from the previous answer is 2 pi and 4 pi delta omega plus 2 over j omega and multiply with exponent minus j 2 omega. Okay? Okay, next question is find the Fourier transform of xt over 3 where the xt is 1 plus 2 ut. So xat equal to 1 over a x omega over a. Okay, so this is the scaling. So x 3 over 3 t over 3, you will get 1 plus 2 u t over 3, right? Because of the xt is 1 plus 2 ut. So you change the t to t over 3. So from here you will get 1 over 3 modulus x omega over 1 over 3. So this is the scaling. And then you will get 1 over, so you will get directly 3 lah. Okay. 3 with 4 pi delta omega over 1 over 3 plus 2 over j omega over 1 over 3. So you will get 3, 4 pi delta 3 omega plus 2 over j omega 3. Okay, so you just combine the things. So it's rather simple. Okay, understand? Do you understand? Now we go to look at the new properties, that is convolution. Okay, let's look at the example. Determine the convolution of the x1t equal to exponent negative 2t ut and x2t equal to s1 negative 6t ut. So using the Fourier transform convolution, you need to using convolution property of a Fourier transform, you need to find the convolution. Okay, so the convolution property of Fourier transform is like this. Convolute with the x2t, you will get x1 omega, x2 omega. Okay, so you x1, x2. So x1 omega, x omega, sorry, x omega is referred to the x1 omega, x2 omega. So, okay, so x1 omega, x1 omega. So you will have x1 omega, you will have the 1 over j omega plus 2, and x2 omega is 1 over j omega plus 6. Okay, so x1 omega you get 1 over j omega plus 2, and x2 omega you get 1 over j omega plus 6. So by using partial fraction expansion, you get s equal to 1 over s plus 2, okay, s plus 2, s plus 6. So you will get a over s plus 2 plus b over s plus 6. So you assume here, you assume the j omega is s, so easy. So what is a? A is equal to s plus 2 multiply with 1 over s plus 2 and s plus 6. When s is equal to negative 2, then you will get 1 over 4. Then for b, you will get s plus 6 multiply with 1 over s plus 2, s plus 6. When s is equal to negative 6, then you will get negative 1 over 4. So your x omega actually is referred to 1 over 4, 1 over j omega plus 2 minus 1 over 4, 1 over j omega plus 6. This is because you substitute the value of the a and b. Okay, you see that you substitute the value here, the a and the b, okay, to the original question. So you get the x omega, and then using the Fourier transform pair tables, you get the xt. So xt is 1 over 4 exponent negative 2t minus 1 over 4 exponent minus 6t ut. That's it. Using the convolution property, you convert the xt to x omega first, and you convolute. And you multiply, you multiply. If you convolute in a time domain, so you multiply in the frequency domain. Class, okay, next example is find the inverse Fourier transform of the x omega equal to 1 over 4 plus omega square using convolution property. So convolution you also can use for the inverse Fourier transform. So now your question is x omega equal to 1 over 4 plus j omega square. Okay, j omega square, 4 plus j omega square, so you can factorize it into 1 over 4 plus j omega. So okay, so this one will be if in frequency domain, you will get it like x1 omega multiply with x2 omega. So this one is the convolution property. Okay, as you know, the x1t is the inverse Fourier transform of the x1 j omega. So you will get okay, so the inverse, inverse of the 1 over 4 plus j omega, you get exponent minus minus 4t ut, right? For the x2t, you get exponent minus 4t ut. It's the same things. So by using time conversion property, xt equal to the x1t convolute with the x2t. So the conversion is from minus infinity to infinity. X1 tau, x1 t minus tau d tau. So it's from 0 to t. X1 tau, you get exponent minus 4 tau, and then exponent minus 4t minus tau. This is quite similar with the previous chapter, okay, for the conversion, chapter 2, if not mistaken. Okay, so you continue with this one. Alright, so you multiply in with everyone, with each one. So you get exponent 4t, exponent positive 4 tau d tau. Okay. So you take out the exponent negative 4t because what you want is just the tau in terms of tau. So it's in terms of t, you take it out. It's as a constant. Okay, so exponent negative 4t, 0 to t, you get what? Negative 4t plus negative 4 tau plus 4 tau, you get 0. Okay, you get 0. So when you get 0, so it's exponent 0. Exponent 0, you get 1, right? Exponent 0, you get 1. So integrate 1, you get tau. So substitute the value of tau into t and 0. So you get t minus 0. So you multiply in, you get t exponent minus 4t ut for t more than 0. Okay, class? That's all for the conversion in time. And we have finished the properties of the Fourier transform. Okay, hope you can understand. Thank you. Bye.